In this lesson, we will delve into Task 6.1.1 from Project 1, which focuses on the components and assembly of modular fixtures, specifically the characteristics and advantages of modular fixtures. In the field of machine tool processing, modular fixtures hold a unique position as they can combine different components to meet diverse processing needs. Next, we will explore in detail their specific characteristics and the advantages they bring to actual production. Among the various types of fixtures in machine tool processing, modular fixtures hold an important position due to their unique design and functionality. Modular fixtures are assembled like building blocks from a set of pre-manufactured standard elements and components tailored to the processing requirements of the workpiece. These fixtures have many notable characteristics and advantages, which we will explore in detail below. First, let's examine the characteristics of modular fixtures. 1. Flexibility and versatility. One of the greatest features of modular fixtures is their high degree of flexibility and versatility. Their standard elements and components come in various shapes, sizes, and specifications, allowing them to be combined in different ways to accommodate workpieces of various shapes, sizes, and processing requirements. For example, in machining, when milling key slots on shaft parts of different diameters, we can adjust the position and angle of the locating and clamping elements in the modular fixture to accommodate different shaft parts. This is akin to having a universal toolkit, where the tools can be flexibly combined and used for different tasks. Such flexibility significantly broadens the applicability of the fixture, reducing the time and cost associated with designing and manufacturing dedicated fixtures for different workpieces. Reusability. The elements and components of modular fixtures can be used multiple times. Once a workpiece is processed, the modular fixture can be disassembled, and its elements and components can be cleaned, inspected, and maintained for reuse in assembling new fixtures to meet the processing needs of other workpieces. This stands in stark contrast to traditional dedicated fixtures, which are typically designed and manufactured for a specific operation on a specific workpiece. Once the processing task for that workpiece is completed, the fixture often loses its utility, leading to a waste of resources. The reusability of modular fixtures not only reduces production costs, but also aligns with the principles of sustainable development. 3. Quick assembly and adjustment. The assembly process of the fixture is relatively simple and fast. Since its elements and components are standardized and utilize a modular design, they can be quickly assembled like building blocks, according to a pre-designed plan. Additionally, if adjustments to the fixture are needed during processing, they can be easily made. For example, if it is discovered during processing that the positioning of the workpiece needs slight adjustment, we can achieve this by loosening the corresponding bolts, moving the locating elements, and then retightening the bolts. This characteristic of quick assembly and adjustment significantly shortens production preparation time and enhances production efficiency. 4. Precision assurance. The elements and components of modular fixtures are precisely machined and rigorously inspected, ensuring high manufacturing accuracy. During assembly, the use of appropriate assembly techniques and methods can ensure the overall precision of the fixture. For example, when using modular fixtures for whole system processing, precise adjustment of the position and angle of the locating elements can ensure the positional and dimensional accuracy of the holes. Additionally, modular fixtures can further enhance precision by utilizing high-precision measuring tools and adjustment devices. Next, let's analyze the advantages of modular fixtures. 1. Cost reduction, as can be seen from the characteristics of modular fixtures mentioned earlier. Their reusability and flexibility significantly reduce the manufacturing costs of fixtures. For some small and medium-sized enterprises, where production batches are relatively small, designing and manufacturing dedicated fixtures for each workpiece would be very costly. However, using modular fixtures can greatly reduce the expenses associated with fixture design and manufacturing. Additionally, the quick assembly and adjustment features of modular fixtures reduce production preparation time and increase production efficiency, thereby lowering production costs. 2. Increase in production efficiency. In modern manufacturing, production efficiency is a crucial indicator of a company's competitiveness. The quick assembly and adjustment features of modular fixtures significantly shorten production preparation time. For example, during the trial production phase of a new product, modular fixtures can be quickly assembled and debugged, allowing for timely production and accelerating the development process of new products. Moreover, modular fixtures can be easily adjusted during processing, reducing downtime caused by fixture adjustments and increasing machine tool utilization. 3. Adaptation to multi-variety, small batch production. With the diversification of market demand, multi-variety, small batch production has become a development trend in modern manufacturing. The flexibility and versatility of modular fixtures are well suited to this production model. For workpieces of different varieties and specifications, only appropriate adjustments and combinations of the modular fixtures are needed to meet processing requirements. This enables companies to quickly respond to market demands without significantly increasing costs, thereby enhancing their market competitiveness. 4. Facilitation of technological innovation and improvement. The modular design of modular fixtures provides convenience for technological innovation and improvement. Since their elements and components are standardized, they can be easily improved and upgraded. For example, with the continuous development of new materials and processes, the elements and components of modular fixtures can be optimally designed to enhance their performance and precision. Additionally, the open structure of modular fixtures facilitates the integration of new technologies and concepts, such as automated control technology and intelligent detection technology, further enhancing the intelligence level of the fixtures. Here, we must mention the modular components of the Tianjin Modular Fixture Factory, which aptly illustrate the dialectical thinking of breaking down the whole into parts and integrating parts into a whole. The Tianjin Modular Fixture Factory decomposes complex fixture systems into standardized modular components, which is the process of breaking down the whole into parts. These modular components have independent functions and specifications, allowing for separate design, manufacturing, and inspection. In practical applications, these modular components can be assembled into various fixtures according to different processing needs, achieving the integration of parts into a whole. This dialectical thinking not only reflects a scientific design philosophy, but also brings great convenience to the production and management of enterprises. In practical applications, modular fixtures are widely used in fields such as machinery manufacturing, automotive manufacturing, and aerospace. For example, in the machining of automobile engine blocks, due to the complex structure of the block and the high precision requirements, modular fixtures can be flexibly assembled according to different parts and machining requirements of the block, ensuring machining precision and production efficiency. In this lesson, we have discussed in detail the characteristics and advantages of modular fixtures. Modular fixtures are characterized by their flexibility and versatility, reusability, quick assembly and adjustment, and the precision assurance. These characteristics bring advantages such as cost reduction, increased production, efficiency, adaptation to multi-variety, small batch production, and the facilitation of technological innovation and improvement. Additionally, we mentioned the dialectical thinking of breaking down the whole into parts and integrating parts into a whole, as exemplified by the modular components of the Tianjin Modular Fixture Factory. By studying these topics, we can gain a better understanding of the important role of modular fixtures in machine tool processing, laying a solid foundation for future practical applications.